Hello, and welcome to the breakout session on turning a profit with cover crops. I'm Rob Myers, Director of the Center for Regenerative Agriculture and agronomist with the University of Missouri. I also serve as a Regional Director of the North Central Region Sustainable Ag Research and Education, or SARE program. I'm happy to visit with you about some of our work on cover crop economics. I'm going to talk to you mostly about a report that we produced in 2019 that analyzed data from farmers across the country who had shared their information about yield experiences with cover crops and corn and soybean systems, and also some of their cost. And we have that data from a total of 5 surveys that went into this report. We've done one more survey since then. Those surveys were distributed typically to up to 2,000 farmers. Several hundred provided yield data, as I'll explain more in a minute. But anyway, this report is available online. You can read the full report for free, either downloading as a PDF, or if you want to order a print copy or even multiple print copies, you can get those for free from the SARE website as well. Just do a search for SARE cover crop economics. This was a publication analysis effort that I led, working with Alan Weber, an ag economist who also farms and uses cover crops on his own farm, and Sammy Telleton, and then we had about a dozen people review it from both the economics and agronomic standpoint. So diving into this, the first thing we looked at, of course, is cost, and that's really the easy part of the equation, looking at seed cost, obviously, but also the cost to plant seeds and termination. From our survey data, particularly in the early years of the survey, we were seeing that a median cost was about $25 an acre. So we used that as part of our analysis. We also saw that a typical seeding cost was $12 an acre. Now that was if it was hired, such as hiring an aerial applicator, and those costs can vary quite a bit. And then termination's a little more tricky. We found that the majority of farmers were already doing a burn down application in the spring, even before using cover crops. So nothing changed for them when adding a cover crop. They just continued to do that burn down, typically with glyphosate. So in that case, we assumed that for the majority of farmers, there was no extra termination cost. Now, obviously, some would have a termination cost. Others would have no cost to plant the seed because they just have it spread when they're having their fertilizer dealer spread their fertilizer seed with the cover crop. We also see people that are applying the cover crop seed with tillage instruments. So again, same pass over the field, effectively no extra cost other than possibly modifying that equipment. And certainly seed costs can vary. People using legumes and mixes may have a little higher seed cost. If they're just doing something like cereal rye or oats or radishes, their costs could be quite a bit less. They could even be $10 an acre or less. So we feel this $37 an acre number covers the majority of situations. And probably, I think today, a lot of farmers have found ways to economize. And I often hear that many of them are doing it for a total of $20 to $25 an acre. But again, working off this conservative number based on early survey data. And ways that farmers are economizing, just to briefly mention, I'd already talked about species selection. Something like radishes is planted at very low rates, maybe just a few pounds an acre, keeping the cost down. There are farmers that use cereal rye. Some will plant a high rate, like 75 pounds or more an acre, especially if they're grazing. Others may use a much lower rate. I know a farmer near where I live here in central Missouri that only puts out about 20 pounds of cereal rye because he likes to have a little bit less dense stand to plant green into. The seeding method can make a difference. Some farmers will use a big row crop planter that can help them use a little lower seeding rate, and they can also get over more acres to cut some cost. Obviously, if it's broadcast, that can be less expensive. And of course, where they buy the seed. But again, $37 an acre was our figure we used in the calculations. So again, that's the easy part of the calculation for cover crop profitability. The more challenging part is, how do we evaluate yields, cost factors in terms of other inputs besides this cover crop seed cost? And then resiliency is a really interesting aspect of this too. So let's look at these in turn, starting with yields. We did gather yield data, as I mentioned earlier, in the survey. Typically, we had several hundred farmers providing that yield data. 2012 was kind of an outlier from other years because that was a drought year, major drought year across most of the corn growing region. And we found that cover crops really helped in that year, about just under 10% with corn and a little over 10% with soybeans. In fact, when we looked at some of the driest areas in 2012, the cover crop margin was even better. They just really seemed to help a lot of farmers in that situation. In more typical weather years of 2013 to 16, we saw more modest yield increases, typically 2 to 3% for corn and about 3 to 5%, 4% for soybeans. We did have a follow-up year data from 2019, very similar yield data, about 2% for corn and 5% for beans that year. So one thing we found, it's one thing to take an average of several hundred farmers, but it's also, a question of what happens over time. And we could assume that the soil starts to improve over time. Of course, farmers gain experience with how to use the cover crop effectively. So we indeed saw that in the first year of use, there's generally relatively little yield impact, but as time goes by, that impact gets more sizable. So we took 2 years of data that had pretty normal weather years, 15 and 16, and in those years for the survey, we had good information on how long a farmer had been using cover crop in the field that they were providing yield data for it, just in the way we asked the questions. So we were able to do a statistical regression analysis to see what sort of yield impacts they were. These are statistically significant, but relatively little yield impact in year 1 for corn, and then kind of gradually going up by 5 years at 3%. Still modest, but that's enough to make an economic difference. Soybeans responded more quickly, on average about 2% in the first year and up to 5% by the 5th year. Now, I want to emphasize farmer experiences varied widely, even from field to field. We certainly had farmers that had yield losses, especially if they had corn after cereal rye. We know that the corn can be affected by the rye tying up nitrogen. Sometimes the first time a farmer does a cover crop, they maybe don't have the planter set optimally or have quite the right adjustments on it. So certainly there can be yield losses, but these are averages of a large number of farms across a broad geographic area. So I think they're very helpful information. Now, using those yields and also using the cost factors I showed earlier of $37 an acre, and then very slight adjustments for a couple of input costs, especially in the later years, we came up with these numbers. So after 1 year, there's definitely a cost with the cover crop. By 3 years, we're breaking even. Now, this is an average situation. And after that, we're starting to make a positive net return. Again, average situation, pretty typical weather conditions in 2015-16. Now, what are those income numbers based on? Well, at the time we were doing the calculations in early 2019, prices were quite a bit lower than they are now. Soybeans were running about $9 a bushel and corn about $3.50 a bushel. Of course, they're much better now, fortunately. And so the higher crop prices would help those cover crop returns come about more quickly. For both of the crops, we assumed an average of $2 an acre savings in erosion repair. Now, if a farmer had a flat field, didn't have much wind erosion, they might not see that, but other farms might see a bigger return. And beginning in year 3, we assumed a slight savings in weed control costs, none in year 1, and then slight savings in fertilizer costs a little later. And all that's spelled out in detail in the report. So just to come back to this summary slide, again, there's this cost in year 1, breaking even in year 3. So certainly as an investment, it seems reasonable probably to look at cover crops, but for a farmer that, has tight margins, they may say, well, why should I do this if it's going to cost me money this year? I can't afford to, to do this. Well, I would suggest, for those of you that are working with farmers, or if you're considering it for your own farm, there's a lot of things we do on corn and soybean farms that don't pay off in year 1. For example, a lot of our farmers apply agricultural lime, and we know that typically has a 2 to 3 year payoff, not too unlike the cover crops, but it's a very routine practice. So I think we need to be talking about how the cover crops are investment in the soil and the productivity of the soil. We also know that there can be equipment that takes time to invest, so that's another example. But so far, I've talked just about averages. What about specific management situations? I often hear farmers say, well, it's great that cover crops help a lot of farmers, but what are they going to do for my specific field situation or my specific farm? So the rest of my talk, I want to focus mostly on that, how different management situations or challenges might alter the picture for cover crop profitability. Let's start with herbicide-resistant weeds. One of the biggest problems that's emerging across the Corn Belt. They've been kind of gradually becoming worse in many areas, moving up from the south. Or my own family farm in central Illinois, they've started appearing here in the last few years. If you talk to cotton farmers from the south, there are farmers that have lost entire crops to these herbicide-resistant weeds. And the troubling part is many of these are becoming resistant every year to more modes of herbicide action. So if you've got this situation, and over half the farmers in our most recent survey did have herbicide-resistant weeds, what does that do if you're bringing cover crops into the picture? I'm going to start with the bottom line conclusion, and then I'll explain how we got there. So with herbicide-resistant weeds, we concluded after doing quite a bit of analysis that you could have a typical savings of $27 an acre. Again, could vary widely, could be much less, could be more. But if you had that $27 savings, that would make the cover crop pay off in year 2 for corn and actually in year 1 for soybeans. So that's a pretty dramatic difference from having to wait 3 years to break even. Now, what are we basing that on? Well, again, we found over half the farmers were reporting herbicide-resistant weeds. We did not assume any difference in yield. Certainly, if you had herbicide-resistant weeds, you could have a yield loss. So that would be favorable if the cover crops are helping, or grain dockage, which could be another way farmers would lose money. So we just assume no changes there. What we do know from talking to a lot of farmers in our survey data is that often farmers trying to deal with these troublesome herbicide-resistant weeds are putting on 1 or maybe even 2 extra post-emerge applications over what they normally did. And they're often using more expensive residual herbicides. So what we evaluated based on this 27 an acre was that we assumed a $12 an acre savings from 1 fewer post-emergent spray. Now, we're not saying they're going to avoid any post-emerge spray. We're saying we're not going to go from 1 to 2 or 2 to 3. And we're assuming that's Roundup Power Max just as an example. And you can see the cost there based on early 2019 figures. We also assumed that a farmer might have a savings of $15 an acre by using less expensive residual herbicides. Again, we're still assuming the farmer is using herbicides, residual herbicides, but just not having to go to more expensive chemistries. So you put those two together, you come up with $27. And I just want to emphasize, we know those experiences can vary widely. Our most recent survey done after this economic report showed that indeed farmers reported a range of herbicide savings, but the majority were reporting savings. So that's one scenario where cover crops can pay off more quickly. What about compacted soils? When we were working on this report, finishing it up in 2019, we had tens of millions of acres that had very wet spring conditions, lots and lots of soil compaction. There was a good study in Ohio, Ohio State University, looking at the impact of subsoiling versus cover crops on soil compaction over a several-year period. And in short, they concluded that cover crops were a superior tool for dealing with compacted soils. Now, certainly the subsoiling can help short-term, but the cover crops seem to provide more long-term benefits. The yields are better, and they can be a lower-cost solution. So University of Minnesota has a big machinery cost report that they put out annually, the best one in the country, I would argue. And in their report, they would suggest subsoiling is $15 an acre cost, $15.30. So if we can avoid that subsoiling operation by using cover crops, then that makes them pay off in year 2 for soybeans and break even in two years for corn. So certainly a scenario that some farmers would be dealing with. What about fertility? We know this year that fertilizer costs are sky high. In a lot of cases, they've doubled, like anhydrous ammonia, over what it might have been a year or 2 ago. Or we may have a situation where we have a field that somebody's just started renting that's very low in fertility. So if that's a big focus for a given field, how does that factor into looking at cover crops? Well, here, assuming the field situation where the cover crops can indeed help short-term with soil fertility, we concluded that cover crops could help break even in year 2 for corn, so a year earlier. But for soybeans, not much of a difference. So maybe a little bit of phosphorus and potassium. The key is with corn where we can get that nitrogen savings, particularly by using a legume. Now, the details of the numbers of that are in the report. For time reasons, I'm not going to go through all that. I would point out that organic farmers are sometimes using cover crops with legumes, in particular, to supply most or all of their nitrogen needs, but that's assuming a longer period of legume growth than what we assumed here, and a later planting date for the corn or certain other crops. Here's an interesting one. We find, over time, a lot of the farmers that have converted to no-till experience what is often pointed to as a yield dip, and maybe that happens for a year, maybe it happens for 2 or even 3 years. It's not fully understand why all that happens, but the assumption is that part of it is compaction of the soil by suddenly stopping tillage. It takes a little time for the macropores and the improvements in the soil to form better aggregate structure. Maybe a little less distribution of the fertilizer being applied in the root zone at first until the soil kind of recalibrates to being in a no-till situation. But what's interesting is that farmers that have jumped into cover crops often then want to add no-till because of the soil health benefits. And many of them are finding that they're not getting that yield dip. We need more research on this to prove that that's the case, but I think there's enough evidence this is happening to say for at least some farms and fields, this is a scenario where starting with a cover crop, let's say we start with cereal rye, and then do no-till the next year, like with soybeans, we can avoid much of that yield dip. Now, if we look at it that way, there's a savings here of almost $24 an acre, mainly because of the labor savings on the no-till. We're not having the extra trips over the field, less fuel and labor and equipment cost. So that can make the cover crop break even in year 1 for soybeans. If somebody was kind of thinking about moving to no-till anyway, starting with that cover crop like rye before soybeans, and then doing it could make it pay off potentially in a year. And that, another very significant aspect of using cover crops for profitability. So again, we're looking at the potential impact of a normal yield dip, looking at eliminating a fall chisel operation, $11 an acre, and then a couple seed bed preparation passes. So that's where we come up with that, just under $24 an acre. What about grazing cover crops? This is often cited as perhaps the most rapid way to make cover crops pay. And I think that's a good argument based on all the numbers I've seen. So there's a couple ways you can look at grazing. You can look at it from how much rate of gain are the cattle or other grazing animals making. And of course, that depends on how long they're grazing, how much forage is there. Or you can look at the hay replacement value. And that's the method we chose to use. This effort on developing kind of a analysis of the grazing was done by Alan Weber, who actually grazes cover crops on his own farm, an ag economist, and did a detailed assessment of this. So he determined that we could get an extra return of about $49 an acre from grazing. And that makes cover crops pay off in year 1 for both corn and soybeans. Now, we're making a couple of assumptions. One is that we have some portable electric fencing already available in the farm. And the other is we've got some way to provide water. Either there's a pond or there's a portable water tank available that can haul water to the field. And that's what a lot of these farmers are using that are grazing cover crops. They're not necessarily putting in permanent fencing. However, if somebody came in and put in, permanent perimeter fencing, needed to buy the electric fencing, needed to buy some watering setup, then certainly that's going to delay the return from the grazing. It might be 2 years, even in some scenarios could still be 3 years if they had a lot of upfront costs. But the bottom line is it can be done in a year to make it profitable. And that's why we're seeing many farmers doing this. So let me tell you a little bit more about what Alan Weber calculated. So his assumptions were that the cereal rye was generating about 1,500 pounds an acre of dry matter. that about half of that rye biomass was being lost to hoof action and selective grazing. And by the way, 1,500 pounds, that's a pretty conservative number. Rye can certainly generate more, considerably more biomass than that. And then he said that 750 pounds of rye, half of what's produced, could replace a little over 1,000 pounds of hay, because he assumed that about 78% of the hay would be utilized and that the hay had 88% dry weight. He valued the hay at $80 a ton. Again, this was early 2019. We were pulling together those numbers. And he assumed that there was an additional savings of $5.50 per acre for reduced machinery, fuel, and labor costs from not having to haul the hay. So you put all that together and assume that you've already got some electric fencing and water. That's where you come up with the $40 an acre. Now, I have seen other studies that showed even higher returns, and I've also seen some individual case studies where farmers had lower returns. It really just depends on how much grazing they have available, but bottom line, for the majority of farmers grazing, this can be a pretty profitable approach. Now, another thing I think we sometimes don't think about enough with cover crop profitability is the role of incentives. And if you haven't been watching this closely, there is far more incentive funding for cover crops than ever before. I mean, if we go back even just 3 or 4 years ago, I would guess that nationwide, we probably have almost 3 times the investment we did a few years ago. The biggest single program, I think, is the Natural Resources Conservation Service Environmental Quality Incentives Program, or EQIP program. Each year, those rates are adjusted slightly. These are 2019 rates, and each state can set their own rates. The basic rate is for a single species of cover crops. There's a higher rate if you're planting 2, or in some states you're required to have 3 species of cover crops. And then higher rates are available in many states for certain scenarios, like for beginning farmers or organic farmers or underserved farmers. But even just looking at the basic rate here, we can see that typically in most states, it's around a $50 an acre payment. There are some that are lower in the 40s. Probably the lowest end is like Minnesota and Iowa at $34 an acre. But, you know, going back to those costs, we found that if you had just at least $32 an acre payment rate, that's allowing the cover crops to make money in year one. And if you're making $50 an acre, then you're definitely making a profit. Now, EQIP contracts are normally for a 3-year period. There are other incentive programs like the CSP program that are 5 years. That's a little bit lower rate, but it's packaged with other conservation payments. We're seeing soil carbon payments from private companies now, typically a little bit lower, maybe $5 to $10 an acre. But the key thing here is that there is a variety of payments available. Okay, I want to finish with resiliency and managing soil moisture. I think this is one of the things that's hardest for us to put the numbers on, but yet at the same time, it's one of the areas where there's the biggest economic impacts. And I would argue one of the most important reasons we should be looking at cover crops. So many of you have seen a rainfall simulator where there's some trays of soil that have been carefully sliced out of the soil with a spade. And these are typically about 1.5 inches deep. These aluminum trays have, or galvanized trays have holes drilled in the bottom. And then about 1 inch of rainfall is applied by an overhead sprinkler. Any water that's not soaking in runs off the front and goes into the jars in the front. And any that does soak through the soil goes into the jar in the back. So you can see here that the bare soil, that's the conventional tilled soil, most of the water is running off into the front, very little soaked through. By contrast, the cover crop there with the green plants in the middle, very little ran off and most of it soaked through. Now, the first time I saw that several years ago, I thought, well, yeah, kind of makes sense. But it was this next part of the demonstration that really grabbed my attention. When the person doing it flipped over the 2 trays, the tilled tray and the cover crop no-till tray. The tilled soil is here in front, and the water, the inch of rain has not soaked through that very shallow layer of soil. And look at the cover crop no-till in the back where most of it is soaked through. And we saw that with the jars. And that just sort of blew me away. You know, my dad always said, well, if we rough up the soil, it'll soak up the rain better. Well, it intuitively seems that way, but what happens with many of our soils is that soil will seal shut as the rain starts to come down. And the harder the rain, the faster it seals up. And if we don't have the macropores created from earthworm channels and so on, then we don't get that water soaking in. So let's look at it another way. Let's just visualize a cover crop no-till situation like on the left, tilled soil on the right, and just think about what's happening in that vertical profile. So that tilled soil on the right, yeah, it's a nice uniform upper horizon. Now we may have some restrictive plow plan, but more importantly on the left, we've got all these macropores, these channels from earthworms that are tunneling both vertically and horizontally. We've got root channels from decaying roots of both the cover crop and the cash crop. And all those things allow the rainfall to soak in much more quickly. And this is well documented that the rain infiltration rates are much higher in a cover crop no-till system than in a tilled conventional system. Getting that rain into the soil makes all the difference, of course, in a dry year. And that's, I think, part of the reason among several that we saw those yield benefits in 2012. Now, there's other reasons. If we have a good cover crop residue, that reduces some evaporation of moisture from the soil and keeps the soil cooler. That helps during stress and dry times. We have more mycorrhizal fungi. And those fungi, we've learned, play a really important role in providing nutrients and even water sometimes to our crop roots, like our corn roots. So you could think of it in very simple terms. If we have a lot of mycorrhizal fungi, it's like that corn can access a bigger volume of the soil for water and nutrients, especially in a dry year when the corn roots might not have grown very well otherwise. What about if we have something like soybeans and soybeans? We have a lot of that in Missouri where farmers will plant soybeans continuously. If they have a cereal rye cover crop in between, our data shows that cereal rye generally will root more deeply than soybeans, especially the first time that it's used with soybeans. And then the next year, the soybean roots can go down a little deeper because they're following those cereal rye root channels. So again, that soybean's going to get to more water and nutrients. So putting all that together and looking at the data we had from 2012, we determined that in a dry situation, that corn could have a net advantage of $58 an acre and a little bit more on soybeans, $65. And that allows cover crops to pay off right away and pay off very well in that first year of a drought year. Well, we don't have a drought every year. Sometimes we have a really wet year, like in 2019. How does that factor in? We're still looking more at the yield data impacts. We saw in that year that there was not as big of a yield impact across the course of our study, but we're doing a further assessment on that with actual farm data from USDA. But this is just one visual example I would share with you. This is a farm in Oklahoma in the spring of 2019. The farmer that provided the photo had been a long-term no-tiller with several years of cover crops on the field to the left. To the right is the same soil type, but the conventionally tilled field with no cover crops. Now you can imagine which field is going to be planted first. It's going to be the one on the left, right? With that standing water and all that water in the ditch, it's just not going to be possible to get in there and plant very soon. And we had a lot of standing water. There were 19 million acres that could not be planted in the year 2019. So this is a big deal, that kind of resiliency. We're finding more farmers are planting green. This is kind of unimaginable. A decade ago, we'd see something like this where soybeans are being planted into living cereal rye, 4 or 5 feet tall. But quite a few farmers are doing it. And they say that rye or whatever cover crop they have can help dry down the moisture in a dry spring. Now, the flip side is if it's in a wet spring. If it's a dry spring, we've got to think about adjusting termination, maybe terminate earlier. But we're seeing generally the climatologists say more wet springs in the Midwest, and so this can be very helpful. So just to summarize, 3 key aspects of cover crop economics. First of all, evaluating cover crop profitability is best done from a holistic perspective, looking at how to gain efficiency as part of soil health improvements with the overall cropping system. Secondly, much like applying lime or buying equipment, in most cases, farmers need to use a multi-year timeline to evaluate the return from cover crops. And third, one of the most cited economic benefits of cover crops by experienced users is their impact on the resiliency of the cropping system. As with federal crop insurance, the premium paid for planting cover crops will pay off big in some years. If it's an exceptionally dry year, a really wet year, it can really pay off big. Now, we know with crop insurance, it doesn't pay off every year, but we still do that because of that recognition it's going to pay off big at times. And so I think that needs to be part of our calculation in looking at cover crops. Bottom line, we need to value cover crops both for their immediate benefits, and there are several, including soil erosion, and also as an investment in the long-term success and profitability of the farm. So thank you. And again, the full report is available online. Just search SARE cover crop economics, and you'll find that report.